Hello everybody and welcome back. You have officially made it to the start of Unit 3. So today we're going to be going over rock types. So far we've talked about plate tectonics and the way that plates move. We talked about the layers of the earth, but now we're going to start talking about kind of the composition of the rocks on the planet, and we're going to move into talking a little bit more about the lithosphere itself. So today we're going to focus on rock types. As always, you should have downloaded your interactive notebook pages, and we are going to jump right into it. So just a reminder of what the lithosphere is. This is the rigid outermost layer of Earth's crust and the solid mantle, so the upper mantle. Remember, in the mantle, we've got the upper portion that's solid, and then we have that like molten rock beneath it in the lower mantle where the convection currents are that move our plate tectonics. So there are three rock types we're talking about today: igneous, sedimentary, and metamorphic. And there are these brief descriptions here that you can refer back to, but we're going to go into them in depth. So the first rock type we're talking about today is igneous rock. And an example of this would be granite. So if you've ever seen granite countertops in a house or on TV, I don't know if anybody else likes to watch House Hunters on HGTV, but granite is an igneous rock. And igneous rock is formed from magma. So it's a slushy mix of molten rock, gases, and mineral crystals below the Earth's surface. So igneous rocks are formed from the crystallization of magma, and all that means is that the magma cools down. So when the magma cools and hardens, it forms igneous rock, but the cooling is called crystallization. So just a reminder too, lava is magma that flows above Earth's surface. So if we're talking about magma, it's below, and if we're talking about lava, it's above. So there are two types of igneous rocks we need to know about. The first is extrusive. So extrusive igneous rocks are fine-grained, and they cool quickly on the Earth's surface. So if you think about extrusive, out, so ex, outer, so these are cooling on the surface. Intrusive rock tends to be coarse-grained igneous rock that cool slowly below the Earth's surface. So the extrusive over here is shiny and smooth. This is going to be cooled on top of the surface, and then the intrusive, that's coarser, and you can see these kind of distinct pits in it. This is going to be intrusive. So when magma cools, it crystallizes and forms igneous rock. If it cools quickly on top of Earth's surface, there's not enough time for large crystals to form. So it is extrusive, so it's smoother. An example of this is something called rhyolite. If it cools slowly beneath Earth's surface, there is sufficient time for large crystals to form, and this is intrusive. So this is where you would get granite. So granite would be an intrusive igneous rock. So some uses for igneous rock: we can use them as building materials. So they're strong, they're resistant to weathering. Granite is one of the most durable igneous rocks. That's why we use it as countertops a lot. Ore deposits can be found within igneous rocks, things like gold, silver, lead, and copper, and also diamonds. So if you ever want a diamond, they come from igneous rocks. And who doesn't want a diamond, right? So the next type of rock we're going to talk about, so we've already talked about igneous. Now we're going to move on to sedimentary rocks. So much of Earth's surface is covered with sediments. And these are just pieces of solid material that's deposited on Earth's surface by wind, water, ice, gravity, or chemical precipitation. Sediments are formed through something called weathering, and we're going to have a whole lesson on weathering. But basically, weathering is just the breakdown of rocks. So if we talk about weathering, it's just rocks being broken down. And then when the sediments become cemented together, so packed together, they form sedimentary rocks. And sedimentary rocks always form in layers. You can tell if it's a sedimentary rock because it will have very distinct layers. So if we look here, this is a sedimentary rock. You see these like very distinct bands. Those are the layers of the deposition and the compaction that form the sedimentary rock. There are 5 steps to forming a sedimentary rock that we need to know. Step 1 is weathering. So this is the process that breaks the rocks into smaller pieces, and the smaller pieces are known as sediments. Step 2 is erosion. So this is just the process of removing the sediments through wind, water, gravity, etc. 3 is deposition, so the dropping of the sediments. So the sediments will be deposited somewhere. 4 is compaction, so that's the squeezing layers of sediments together. And then finally you have cementation, and this is when dissolved minerals seep into the tiny spaces between the sediments and cement them into a solid rock. So basically what happens is that you have different rocks all over the world that are weathered, and they're broken down into smaller pieces. They're picked up and they're removed. A lot of times this happens with water. You are more likely to find sedimentary rock in places where there's been water or water exists, because water will pick up sediments and move them. So think about like a river will pick up sediments and deposit them at the mouth of a river. It would be a really good place to find sedimentary rocks. So they're weathered, they're picked up, eventually they get to where they're going. So the river will drop it, will deposit it in a certain place, and then over time, as those sediments pack on top of each other, they get compacted down. And then eventually those minerals will move into the pores and it will cement it all together, and you get, voila, sedimentary rock. So the primary feature of a sedimentary rock are the horizontal layering called bedding. So graded bedding is coarser and it's got heavier particles on the bottom layer. And then cross bedding is an inclined layer of sediment moving forward across a horizontal surface. So really all we need to know, all that you need to know, is that sedimentary rocks do have very particular banding in them. So they have very distinct layers, and the coarser deposits tend to be at the bottom. And also, the best known feature of sedimentary rock are going to be fossils. Fossils are in sedimentary rock. That's the only type of rocks where you will find fossils, because over time the sediments compact around the fossil or around the organism that has passed away, and it will make that perfect form. So you will not find fossils in any other rock besides sedimentary rock. So there are 3 different types of sedimentary rock we need to know about. The first is clastic sedimentary rocks. And these are rocks that are broken down under forces of nature, so wind or water, and they're just made of pieces of other rocks. And examples of this are things like gravel, sand, silt, and clay, and these are all components of soil as well. So clastic sedimentary rocks are just broken down by wind and water, and they're pieces of other rocks. So that's the first one. The second one is chemical sedimentary rocks. And this is when water dissolves the minerals and they come out of solution, so they precipitate. Chemical sedimentary rocks are going to look like crystals. So the mineral crystals grow together to make the rock. An example of a sedimentary or a chemical sedimentary rock would be like salt. Salt is a chemical sedimentary rock. So we've got our chemical sedimentary rock that precipitate out and form these crystal structures. And then finally, we have something called a bioclastic sedimentary rock. Bio means life. Okay, so when we say bioclastic, these are going to be made of things that were once living. So plant materials and also shells. An example of bioclastic sedimentary rock is something called coquina, and it's just made of seashells that are compacted together. So some uses for sedimentary rock, oil, natural gas, and coal are all found in sedimentary rock, and we're going to talk about energy at the very end of this unit, but they are found in sedimentary rocks. Uranium is mined from sandstone. Uranium is actually what we use to fuel nuclear power plants. Limestone can be used to make cement, and it's also used for building. And then phosphates can be used in fertilizer, and iron can be found in sedimentary rock as well. So there are many, many different uses for sedimentary rock. And then our third and final rock type for the day are metamorphic rocks. So when high temperature and pressure combine to alter the texture, mineralogy, or chemical composition of a rock without melting it, a metamorphic rock forms. Okay. So during metamorphism, a rock changes form while remaining solid. So basically, metamorphic rocks are just formed when they kind of get pushed down deep into the earth and they're exposed to high heat and pressure. Now, the rock does not melt like it would, in the mantle we've got molten rock substance. The rock in a metamorphic rock doesn't melt completely. Okay, it won't melt completely. It just kind of gets warm enough to where it can be molded and is subjected to high pressure because it's deep within the earth. The pressure will come either from overlying rock or compressive forces during mountain building. And remember, mountain building happens where? At convergent boundaries, continental boundaries. There are two types of metamorphic rocks we have to know about. There's the foliated, and foliated rocks have wavy layers and bands of minerals. So our foliated rock is down here on the left-hand side. And then we have non-foliated, which lacks mineral grains with long axes in one direction. So foliated metamorphic rocks are pretty easy to point out because they do have these just like really wavy bands in them. And not to get them confused with sedimentary rocks that have those distinct layers. These are going to be formed from the pressure and the heat from the earth. Okay, so these rocks are buried. They're exposed to heat and pressure, and it will create these kind of wavy layers. So foliated and non-foliated metamorphic rocks. And that's all for your rock types. So remember, the main takeaways from today are that you have igneous rocks, which form when magma cools and hardens, so the crystallization of magma. You have sedimentary rock, that there's those 5 steps to forming those. They form in distinct layers, and you will find fossils in sedimentary rocks. And then you have metamorphic rocks, which form when they get buried underneath the earth and they're exposed to very high heat and pressure, and it will just mold the rock into something new without actually melting it. So those are your 3 rock types that we're going to do today, and that's it. If you have any questions, let me know, and I will see you in the next one.